Download this code from codegive.com, link in the description below. Certainly. AWS Lambda is a serverless compute service that lets you run code without provisioning or managing servers. Performance tuning is essential to optimize the execution time and cost of your Lambda functions. In this tutorial, we'll cover some best practices for Lambda performance tuning, along with code examples. 1. Understanding Lambda basics. Before diving into performance tuning, let's clarify some basic concepts. Execution duration, the time it takes for your function to run, measured in milliseconds. Memory size, the amount of memory allocated to your function, which can also affect CPU power and network throughput. Cold starts, the time it takes for a Lambda function to initialize when it's invoked for the first time or after a period of inactivity. 2. Performance tuning strategies. A. Optimize memory size. Increasing the memory allocated to a Lambda function can improve performance. This is because AWS allocates CPU power linearly with memory. If your function is CPU bound, increasing the memory can lead to faster execution. Example asterisk. Let's say you have a function that processes images. You can tune the memory size. Python. Import Boto3. Import time. Def lambda underscore handler, event, context. Start underscore time equals time.time. Simulating image processing. Time.sleep, 2, simulating a task that takes time. End underscore time equals time.time. Execution underscore time equals end underscore time, start underscore time. Print, f execution time, execution underscore time .2 f seconds. Return. Status code, 200. Body, image processed. In the AWS Lambda console, you can adjust the memory settings from the default to, say, 1024 megabytes or higher depending on your workload. B. Minimize cold start latency. Cold starts can be minimized by using provisioned concurrency. This keeps a specified number of Lambda instances warm and ready to handle requests. Example asterisk. In the AWS console, you would set provisioned concurrency for your Lambda function. You can do this via the AWS CLI. Bash. AWS Lambda put provisioned concurrency config \. Function name your underscore Lambda underscore function \. Qualifier alias underscore name \. Provisioned concurrent executions 5. C. Optimize code execution. Ensure your code runs efficiently. This can include avoiding unnecessary computations, using efficient data structures, minimizing the size of dependencies. Example asterisk. Instead of loading a large library every time, load it only when necessary. Python. Def lambda underscore handler, event, context. If numpy not in globals. Import numpy. Your logic using numpy. Use environment variables. Storing configuration values in environment variables can speed up your function by avoiding hard-coded values and allowing easy updates without redeployment. Python. Import OS. Def lambda underscore handler, event, context. API underscore key equals os.environ API underscore key. Use API underscore key in your logic. Optimize external dependencies. When your Lambda function interacts with external services, like databases or APIs, ensure those services are optimized for performance. Example of using AWS SDK asterisk. Using Boto3 with connection pooling can reduce latency. Python. Import Boto3. Def lambda underscore handler, event, context. Dynamod equals bot03.resource, dynamod. Table equals dynamod.table, your table name. Response equals table.get_item, key equals ID, 123. Return response.get, item. 3. Monitoring and logging. To understand how your Lambda functions perform, utilize AWS CloudWatch for logging and monitoring. CloudWatch Logs automatically captures logs from your Lambda function. CloudWatch Metrics provides metrics such as invocation count, duration, error counts, etc. Example of logging execution details *. Python. Import logging. Logger equals logging.getLogger. Logger.setLevel, logging.info. Def lambda_handler, event, context. Logger.info, f received event, event. Your processing logic. For conclusion. Performance tuning AWS Lambda functions is a multifaceted task that involves optimizing memory, minimizing cold starts, refining code execution, and efficiently managing external dependencies. By applying these strategies, you can significantly improve the performance and cost effectiveness of your serverless applications. 5. Further reading. AWS Lambda Best Practices, https://docs.aws.amazon.com/lambda/latest/dg/best-practices.html. AWS Lambda Performance Tuning, https://aws.amazon.com/blog/compute/optimizing-lambda-performance. This should give you a comprehensive understanding of how to tune AWS Lambda for better performance. Happy coding!